Okay, good. Hi, my name is Murthy, and for those of you who don't know, I am a brother of Sudheer Murthy, whom you all know very well. I know that he's done something really fantastic out here. He set up something called immersive learning experience. So I want to touch base on that, but before I go that far, why it's so important to have immersive learning? What does it mean for you all, right? From the perspective that I have looked at here, I'm going to give you a little different presentation of it. I normally teach public speaking and youth leadership. I'm trying to bring you that concept over there and how it meshes very well with immersive learning. Right? So first of all, many of you understand that something that human beings we have been endowed with a phenomenal gift of communication. We can order our thoughts and we can communicate it effectively. So what does it require to be an effective communicator, and why is it important for you all to have that kind of effective communication? Obviously, when we want to convey some thought in our head to somewhere else, there's a receiver. You are the sender, they are a receiver, right? And what you want to send will become a formulated message. So message is important, of course. You may be very good at formulating a message, but it's also equally important to make sure that your message reaches somebody effectively. Of course, the simplest form of communication is verbal, which we all do today, right? And of course, it requires some sort of skill. Now, of course, when you're speaking one-on-one in a familiar environment with a familiar person or people, you tend to be a little effective there. But when you're talking to strangers, especially over a vast audience, which you all have proverbially heard of, is a stage fright. It happens to all of us. So our message becomes incoherent, we start lose focus and everything. Aside then from that fact, now when people talk about education, I want to talk about something in my childhood when I grew up here in Hubli, in the school that I attended. It was a small school, all of us attended, with not too much facilities. It was an imaginative world. We didn't have facilities, a good chemistry lab or a physics lab, pretty much nothing. It was left our imagination. Maybe it helped us become better at imagining things, how things work, etc. But we always wished we had the capacity to learn with something in front of us, which we could touch, we could feel, we could look closely into, immerse ourselves into that. You get it? I'm talking about immersive, right? So, what we were fortunate, the educators in those days, especially one that I pay a lot of respect to, Dr. Kashin Kunti, we call him Dr. Kashin Kunti because Dr. Kashin Kunti, and he had that immense power of communication. In fact, I would still say, not a single day I opened up a history book to read, because whatever he taught in class, he would bring the picture in front of me and I could literally visualize. We learned the dates I was able to memorize, the names I was able to memorize, actual wars that he spoke about. I felt that I'm in the battlefield. It felt so immersive, but that was imaginative immersion, right? But sometimes science is all about proofs. Science is about something that you want to touch and see, something you want to feel about it. That's important too. But then again, for a single teacher, however good he or she is, like my brother, I know he's an excellent teacher. He taught me. Okay, much of what I am today, I owe it to him too. At the same time, it was very simple for him to teach just to me. He knew me very well. There was familiarity, and he also knew what I know and what I don't know. But when he has to teach to a lot of students, he has to reach a lot of students because his expertise is valuable. His time is valuable. He cannot scale himself 10 times. He also has only 24 hours a day. But the number of children who want to learn from him is growing massive. He has to scale it. So what's the best way to do that? From what he explained to me, Government of India came up with the initiative of immersive education. He mastered it. And something that he showed it to me was fantastic. So here he has a presence of in-person students who participate in that, right? And now I'm requesting him to show me the different areas. So would you mind please showing me what you have out here and how people can educate themselves, both in person as well as somebody who's sitting remotely, somewhere or in some other corner of the globe. Could you please show that?
So here you find that you've got a lot of apparatus, mainly physics. So I can teach students while experimenting. So the concept is experiential learning. Now I'll show you something here. Okay, so as you can see, Let me zoom this for you. Just zoom it. So there are many things that
so when you say experiential learning, right? So I want to understand one thing very clearly, just before you start, if you don't mind. So it's all about, anyone could have a recorded video and they can learn from it. Let's say the modern technology allows you to do that. What you lose touch is interactive. You should have the ability to ask a question and you should get an answer in real time. So that is something I'm assuming that is you are providing as part of this experiential learning, right?
That's right. It is experiment, experience, and learn.
Good.
So in other words, there are many students who say, well, we don't need a textbook. And some say, find that, anybody can learn physics like this. So I'll just show you one. So there is something that students love. So in the textbook, they have said, well, magnetism. So about trains getting leviated. That's mentioned in the textbook of high school, 9th and 10th standard. So I made a model here. So you can see, this is just a copper wire which is wound here, and there is a magnetic material inside this. It's pretty heavy, and then I have got a copper plate.
Okay.
So I'm going to turn on. This is AC source. So I'm giving the AC current to this. So the AC current circulates in this coil, and then when I turn on, okay, the AC current is circulating. I'm just keeping a copper plate. You can see that it is leviating. Okay.
So it appears to be levitating.
Yes. So you can assume that this is a train. Right?
Yeah.
And the entire train is going to get levitated.
So this is the concept behind the magnetic levitation.
Yes.
What they call maglev, right?
Yes, maglev. Okay. And now this is a copper plate. Now I'm going to experiment with the aluminum plate. Right? I'm just keeping my hand because you see what happens now here. It's going to fly up. So you can see. Alright. And then I'm going to experiment with the same aluminum plate, but it is not.
It's a little thinner.
Thinner and
So there's a notch out there. Okay.
Right. So I'm going to turn it on. Now you see nothing happen. Okay. So the theory for this, the students do learn in their school textbook.
Okay.
And then you have to explain this.
Absolutely.
And then of course some diagrams and things. And then see, I'm going to do something here. Again, this is a bulb which is connected, copper winding. Just going to keep it here. Right? You can see the bulb glowing. Okay. Right?
Yes.
So we can see it glowing.
Yeah.
And I turn on, the bulb stops.
Yes.
So, well, the Faraday's laws of electromagnetism, coil states.
So you clearly demonstrated that.
It's demonstrating. I mean, it's it's being used.
Right.
Okay. But the relevant theory for this has to be learned, but with some different experiments.
Okay.
So in my laboratory here, I can conduct many experiments here, right? So I've got one more experimental setup here, right? So here you can see the famous Faraday's coil as a galvanometer here.
So we see the needle move.
Yeah, we can zoom this to suit the students. So I can explain experiment, of course, tabular column, things like that.
Yeah.
You can see that the galvanometer
So
is
the needle is
deflecting.
moving.
So I can explain this. I'm just demonstrating it, but in detail we can show this here.
Good.
And
So the popular saying goes, right? A picture is worth 1,000 words.
it's
right?
not just a picture.
No, I'm just saying, in terms of, let's say, let me paraphrase that, or if I could borrow from the same phrase, it's not a picture, a video could be 1,000,000 words, let's say. Right?
It's even not a picture or a video.
Right.
So
What
here,
I'm trying to say is in real time.
see here,
Interactive.
students will be here. You can see that this is a classroom. So of course I'm showing an empty classroom. Here the students themselves conduct the experiments. Right?
Yeah.
And the most important thing is, this is a very small setup. Okay? You can see the setup is just the size of my palm. Okay? Now imagine students, say about 5-6 students, they want to learn. So around the table, you can have maximum 3 or 4 students looking into it.
Okay.
Now in a classroom, say of 40 students, or even say 10 students, this one small setup is not be sufficient.
Okay.
And here the advantage is all this, is captured on the screen. So it is enlarged. So now everybody here sitting in the classroom, 40 students, they can view it.
Exactly.
And for me as a teacher, right? So I have the luxury of, I want to explain something here. I can take a snapshot of this, right? I can just take a snapshot of this, and I can use that snapshot for further analysis. Okay, say I can freeze this, I can take it. See, the camera is still working. All right, my camera is still floating. So, but I have just captured a screenshot of it, and now I can analyze on this. So I can say, like, students, watch out, this stylus, it is moving, when the magnetic field through it is changing, right? And I can tell them. So you can observe very carefully the stylus is moving. You can see that, and if I move this slowly, the movement is very slow, or the amplitude of the stylus is very less. But when I move it fast, the amplitude is more. That shows it is something to do with the rate of change of flux. So of course there is many things to be done about the experiment. It takes some time, but it's just a demonstration that I can conduct experiments. So here I can conduct. There is one more table. So I can conduct one more experiment here, and this is a typical setup. So I can got one more setup here. I can conduct one more experiment on this table, right? And again, many students can stand around this table and they can conduct it themselves. And then on the board, it is amenable for analysis. So the system of education, especially teaching physics, becomes more effective and efficient.
Okay. Could you please zoom out a little bit on this?
Zoom?
I have zoom out.
Zoom out?
Out, yeah. It means like
make it
I
small.
want to see the whole setup.
Okay, let me try.
So I believe that you have an interesting story behind this also, this setup, right? I believe a group of your students, they had to do some kind of a project.
Yeah.
And I believe you told them, why don't you take this with you, because they are so short of time.
Yeah.
And I believe they went to a state competition, and in a very short time, they were able to demonstrate, what this setup can do.
Yeah.
And I believe they won the second prize to the state.
Yeah,
right?
that's very true, very true. Here you see, this was just a model that I made. Of course, mechanics, electricity, magnetism, for all the high school. So you can conduct many experiments on this. So there is some setup and all I have done. I have carefully designed it so that there are many things that I can do. And interestingly, the students said, well, we want to make a project for the exhibition. I said, what will you do? So I just gave them this and said, you demonstrate it. I trained them how to use this. They did use it, and luckily they won good prize, second prize at the state level exhibition. So the theme was learn physics without textbook. Okay, and that really was appreciated.
Exactly. I mean, that fits into my analogy, like when I talked about history, when our teacher explained the thing and he brought everything to real life. You are doing something similar with science.
Okay, not so great, but anyway.
Well, of course.
Yes, but it's all the will of the God, and almost all the experiments of high school, 9th and 10th, okay, they can be, I have got things to conduct it. Okay, that's it.
That's very nice. Excellent.
Okay, Vijay, thank you so much.
No problem,
okay.
anytime.
Nice of you.
I'm very impressed, and I'm looking forward to seeing more interesting, I wouldn't call it improvements, but enhancements to what you've already done.
Yeah. Thank you.